Here's a problem involving fractions. Let's read through it. Solve 3 halves minus x minus 3 divided by 3 equals 3x over 5. Well, what do you do with the fractions? And it's possible to get common denominators and add these things together and work it that way. But it's not that practical. The best way to approach these is to find a way to rescale the problem so that there are no more fractions. And so literally by rescaling, we're changing the size. When you multiply by a number, you change the size. And it turns out the least common denominator is your best choice for that purpose. So if you look at 2, 3, and 5, what would be the least common denominator of 2, 3, and 5? That would have to be 30, wouldn't it? It would be 30. So my strategy here is to multiply the entire equation by 30. But first of all, I'm going to attend to one little detail. I'm going to put parentheses around that numerator. And remember we said in the last video, the division line is a grouping symbol. What I want to remind you is that this grouping symbol, this division line, groups x minus 3 together as one thing. In other words, x minus 3 is being subtracted, not just the x. And so this is a pretty important step because in this problem, this is where they're going to mess up the problem, is in the distribution. This is where students make that common mistake that I'm trying to get you to avoid. And so, anyway, that's the idea. Now, we decided that 30 is a good number to work with here. And why is that? Because 30 is the smallest number in which 2, 3, and 5 will all divide into, nice and neatly. And so, I'm going to multiply by 30. And if you prefer, that's 30 over 1. But it's 30. We're multiplying by 30. And we can multiply an entire equation by a number. We're going to distribute. In other words, every term gets multiplied by 30. So that gives me 30 times 3 halves minus 30 times x minus 3 over 3 equals 30 times 3x over 5. Now the miracle of this is that all the denominators disappear, because like I said, when you multiply by a common denominator, the common denominator has each denominator as a factor. In other words, the denominators will cancel out with the numerators. So in other words, 2 goes into 30 15 times, 3 goes into 30 10 times, and 5 goes into 30 6 times. So look at that. No more fractions. So we magnified it. In a sense, we magnified this problem by a factor of 30, and all the fractions went away, which makes it a lot easier to handle. Because now I've got 15 times 3 is 45 minus 10 parentheses x minus 3 equals 6 times 3x is 18x. I wanted to write this out just to emphasize that we now have to distribute, because people tend to skip this step. They'll jump from here to my next step here down here below, and they'll probably put a minus 3 instead of a plus 30. So anyway, let's see what happens. This is 45 minus 10 times x. Minus 10 times x is minus 10x. And, as I said, this is the common error. People overlook this one. We should get plus 30, shouldn't we? Because it's minus 10 times minus 3 plus 30 equals 18x. All right, so you're thinking that, oh, okay, I understand that. I get that. Great. If you don't do much practice, you'll probably make that mistake on a test. Trust me on this. I've been watching this for years. And many people make those mistakes. Okay, well, let's finish up the problem. We can do a little simplifying here. 45 plus 30 is 75 minus 10x equals to 18x. I'm going to add 10x to both sides. And we end up with 75 equals to 28x. And yes, that's visible. Okay, well, I'm out of room, but as you can see, our next step is to divide by 28. I would normally write divide by 28, but that will give us x equals to 75 over 28 as an answer. There we go. So, what's left? Well, some students like to write this as a proper mixed fraction. I've left it as an improper fraction. It turns out that when people go through arithmetic, they get brainwashed into thinking that you're never supposed to leave a fraction like this. And but then you get to algebra and you find out that everybody leaves fractions like this in algebra. This actually makes more sense, because if I were to put this back in here to check the problem, we would want it in improper form. And so it's just the tradition in algebra that we don't worry about improper fractions. We do, however, I do expect you to reduce them, simplify them. And this one does not simplify. There's no common number I can reduce it by. So it's as simple as we can get it. Another mistake students make is they like to pull out their calculator at this point and punch that in. And I don't have I guess I have a calculator right here. What is it? Oh, here's my favorite calculator. 75 divided by 28 is 2.6785714287, and it goes on and on and on, but that's where it stops on my calculator. So, it took me a minute to find my calculator and punch it in. And now, how many decimal points do I give? Why go to that trouble? Just write the fraction. It's algebra, it's okay. Just write the fraction. Don't punch it on your calculator. In the real world, if you need this decimal number, you can punch it on a calculator and use as many decimal points as you want to. One mistake people make is they'll write 2.6 or 2.7 for the answer. And they've cut it off so far that they've removed a lot of accuracy. So just keep it as a fraction. Make life simple that way. Okay, well, there you have it. And again, please pay attention here. I've been trying to get people to not make this mistake through the years, and I'm trying yet one more time to do so. Now we could also simplify the problem, and check the problem is what I meant by plugging that in there, and it's a bit of work. Why don't I just show you, because probably some of you need a little bit of quick arithmetic review. So I'm going to check this without a calculator by using the fractions as is. I moved my answer up here so I can have some room to check. So let's check it. And this is going to be good for you. Alright, we check it by plugging the number in. So I have 3 halves minus 75 28ths minus 3 divided by 3 equals 3 times 75 divided by 28 divided by 5. Okay, well, let's see, 3 halves minus, I need a common denominator here of 28. So 3 times 28 is 84. So that's 75 28ths minus 84 28ths divided by 3. Let me put that in parentheses. Equals, well, I need to do 3 times 75, and I can also divide by 5. Let's do 3 times 75. This would be, what is that, 225 28ths. And when you divide by 5, it's the same as inverting and multiplying by 1/5. So it's kind of awkward to have this complex fraction, but we can, take out the divide by 5 and replace it by times 1/5. All right, let's see, it's going to start looking better here finally. 3 halves minus, now 75 minus 84 is minus 9, so I get minus 9 28ths. And I'm going to write that a little more legibly, a little bigger. So this is minus 9 28ths. And like I did on the right side, I'm dividing by 3. So dividing by 3 is the same as inverting and multiplying by 1/3. equals, over here, 5 will cancel with 225, 45 times. That helps. Down here, those negatives will cancel, and the 3 cancels the 9. So I've got, let me write this. This is 45 over 28. All right, well, I need to make room here, so let me do a little erasing. Boy, if you could do this, you'd be in, reliably, you'd be in really great shape with all your arithmetic skills and algebra skills if you do these kind of checks. I find most students don't have the patience for this, and most students don't do as well as they should. So that's probably why. Okay, so I have 3 halves plus 3 over 28 equals to 45 over 28. Well, I need a common denominator. I need to make this a 28. I can do that by multiplying by 14. And so 3 times 14 is 42 over 28 plus 3 over 28 equals 45 over 28. And finally, we add our fractions on the left. 42 plus 3 is 45. 45 28ths equals 45 28ths. So it checks. We got the right answer. So aren't you glad you stuck around for this? Okay. It's always a good feeling to check one of those and see that it comes out right. Now, if the left side didn't equal the right side, then there's a mistake. Either the original answer is wrong, or unfortunately you might have made an error in the check. But so if you get the left side doesn't equal the right side when you're checking, it's not a no solution problem. It's a I screwed up problem. Okay, it's a mistake. So then you need to go back and try to find the error. All right, well that wraps up this section.